Hi guys, I hope you took some time to practice the student activity that can be found under the systems of linear equations with three variables. Obviously, to check your work, all you have to do is plug your solutions into the equations and make sure that it equals what it says it equals. If it does, then you can be assured that you have found the correct solutions. If it doesn't, then you might have some errors somewhere in your work, and you'll need to work them out and try to figure out where you went wrong. Now, we are going to move on. We're going to talk about systems of nonlinear equations now rather than of, linear equations. Remember, linear equations are when you have two lines or three lines or four lines, any number of lines, and they meet at a specific point. For instance, if you have three lines and this happens where all three lines don't meet at one point, then this has no solution. Okay, because there are three lines and they all must meet at a specific point, one single point, but unfortunately that does not happen in that case, so that would not be good. But if you had three lines and they all met, at this point here, that would be fine, that would be a solution to the system, and so on. But it's not always the case that you always have lines that you're looking at. Sometimes we have nonlinear graphs, which are things like parabolas. For instance, you could have this parabola intersected by this parabola, and you can see the solutions for these two are there and there. And if we had like a line that went this way, then this one over here is no longer a solution, but this one still is because it still is in contact with all three equations. And so I hope that helps you understand when something is a solution to a nonlinear or a linear equation. But this time we're going to talk about any shape that's nonlinear. So we could talk about cubic functions. We can talk about circles. These are not functions at all, but for instance, if that was your circle, those 2 points would be your solutions to this system, and so on and so forth. So let's get going. We're going to solve this equation to the left, and we are going to use substitution to do this. So what I want you to see, remember, if we're going to use substitution, we need to solve for a variable and then plug that value in. So if you notice, we have x minus y is equal to 3. So let's solve for x. We're going to add y to both sides. X is equal to y plus 3. Okay, so now I'm going to plug this into that, where x is, and we're going to simplify this. So if we solve this, we have x minus 2 squared plus y plus 3 squared is equal to 4. We're going to substitute this into this x here. So we have y plus 3, we have y plus 3, that's x, minus 2 squared plus y plus 3 squared is equal to 4, which means we have y, combine these, this is y plus 3 minus 2, that's y plus 1 squared plus y plus 3 squared is equal to 4. If we FOIL this out, we have y squared plus 2y plus 1. I'm just simply doing y plus 1 times y plus 1. Distribute, 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 combine like terms. I have not shown that, obviously, I just skipped to the next part. Next one will be plus y, we don't need that parenthesis, plus y squared. Once again, we are distributing. This is y squared plus 3y, and 3y is 6y, plus 3 times 3 is 9, is equal to 4. Okay, so then we combine like terms. This is going to be 2y squared plus 8y plus 10 is equal to 4. So let's subtract the 4. We have 2y squared plus 8y plus 6 is equal to 0. We can factor out a 2. 2y squared plus 4y plus 3 is equal to 0, which gives us, divide by 2, y squared plus 4y plus 3 equals 0. We can do your favorite thing in the world, factoring, and we're going to get 3 on top, 4 on bottom. That means 3 and 1. 3 times 1 is 3. 3 plus 1 is 4. So this is going to be y plus 3, y plus 1. And so we know y is equal to negative 3 and negative 1. Either one of those is fine. Okay, so with that being said, we can go ahead and solve for x now. So if we have these two values, we know our solutions are going to be y is negative 3 and negative 1. Obviously, this is going to have two solutions, two real solutions. And so if we plug that into x minus y is equal to 3, we have x minus negative 3 is equal to 3, which is x plus 3 is equal to 3, which is x is equal to 0, so this is 0. And one more time, if we do x minus y equals 3, we have x minus negative 1 is equal to 3, x plus 1 is equal to 3, x is equal to 2, and so our two solutions here are the points 0, negative 3, and 2, negative 1. If we were to graph this, that would just mean the following happens. So we've got a point here, pretend this is 0, negative 3. We have the line going this way. This is 0, negative 3. This one is 2, negative 1. And we have our two solutions. We have a line intersecting a circle. And so if we do that, we can see that this has two solutions and that the solutions are real. We'll do more examples of this with different shapes in the next video.